Having said that, let's talk about, or let's go to our first board where I am going to let you know about why behind ICE policies. It is going to be an interesting discussion. So if you are having hard time in reading this red color uh, thing, believe me, it is not for you. This is for me so that I don't forget anything, right? While explaining the board. See, what we are going to do today is we are going to do brainstorming. We will try to think why behind everything, right? Whatever ICE do, we would like to know everything about it, right? So we have Mr. Rahul here. Mr. Rahul is having its PC. Maybe it's a supplicant. We have right here my switch. And from now on, I will be calling it as NAD also. NAD means network access device. Just wait a minute, guys. Yeah, so NAD means network access device. It is exactly at the access of your network. The meaning is if Mr. Rahul wants to access your network, he needs to connect on this device, and I'm calling it as NAD or network access device. The final piece of the puzzle is ICE, Identity Services Engine, and we are brainstorming what exactly this is. To me, it is a server, right? And then basically we install something on top of it, and then it becomes Identity Services Engine. It means that I installed some code, and now today we are trying to understand this code. What is the mind behind this code? Why they have written ICE this way? Why ICE has policies in it, right? So what is happening? First thing first, you all know that we have Mr. Switch, right? And we have the supplicant. Supplicant, or maybe the switch, starts the conversation by asking the identity, and it is going to give the identity to this guy. And eventually, between the switch and the identity services engine, Radius protocol is running, which is going to encapsulate my EAP messages, right? And sending it towards the ICE. This is the whole thing. So first thing first, when we try to design this ICE, Identity Services Engine, what should the very first thing Mr. ICE should know? The very first thing Mr. ICE should know is about what is or where the network access device is. What is its IP address? Maybe it is say x.x.x.x. So first thing first, we have this x.x.x.x guy, which is NAD, right? And we have full IP connectivity between switch and the identity services engine. There is no doubt about it. Why do we need to know about this NAD? We need to know about this NAD is because eventually this NAD will be forwarding all the EAP requests or the response which are coming from the client, right? Mr. NAD is going to encapsulate them into the radius and send it towards the ICE. We know about it, right? But here is my problem. Suppose there is another access switch, which is not part of my organization, right? But I have done routing such a way that it can reach twice, maybe over some network, right? And I am having some guy here who connected on this port, right? This switch is not known to my organization. Maybe I'm part of sportsindia or bridgewire.com, right? But this switch is not part of my organization at all. I should not care about the authentication requests coming from this laptop, right? Although this switch is going to send it towards me, maybe we have configured something between this access switch and ICE. So it is sending the EAP request towards me. But believe me, if I don't tell maybe this access switch IP address is y.y.y.y, and if I don't inform identity services engine that please, if I don't inform that you have only one NAT, which is x.x.x.x, and ICE doesn't know about y.y.y, it is not going to accept any request from it. Because for ICE, it is unauthorized NAD. I do not know this NAD, as simple as that. So first thing first, I should know from where it can expect the radius requests or radius access messages, right? Maybe in India, you have 100 such NADs. Maybe in US, you have 200 such NADs where these access requests are coming. Maybe you can group them together also, that this group of 100 NAD is my India NADs, and the remaining ones are my US NADs, right? So basically inside Identity Services Engine, you can absolutely create the groups of this NAD and maybe the locations of this NAD so that you can take the decision on the basis of from where the request is coming. First thing first, your Identity Services Engine should know where exactly the NAD is. What is the IP address of this NAD? so that it can read, it can understand, and it can open the radius request which is coming from this NAT, right? As simple as that. Now, the second thing is, once this request come to this identity services engine, what exactly identity services engine will look into this request? We need to understand the radius packet also now, right? So you are brainstorming on it and you are developing this identity services engine. You know, at the first step, I should know from where the request should come. I should know that switch address, right? Or maybe the switch's address. Now, once I know that the switch address, right? Suppose the switch has sent one request, which I'm uh, calling as a radius access request message, right? And in this radius access request message, you all know we have the EAP identity message. Maybe in this EAP ID message, I am sending the Rahul username also, as simple as that, right? So you are brainstorming on ISE and you are saying that if any request come to my ISE, I should look into it if it is coming from my known network access device. And now you are opening this request, right? The request is actually the radius access message, and you are opening this radius access message and you are finding multiple things there, right? First thing first, in this radius message, basically you have EAP message. Inside this EAP message, you have the identity, which is saying I am Rahul. And along with that, believe me, there are multiple things inside it, which we call attribute and values. I will be showcasing you, don't worry. We have attributes in the radius message and we have values in the radius message. What is the meaning of the attributes? Maybe one such thing is maybe the name or the identity, right? Or the identity is Rahul. This is attribute, this is value. There are some other interesting values, right, which you haven't heard about. So maybe one such value is service type, which is equal to frame. Don't worry about it. What is the meaning it? I'm telling you. But this radius message has lots and lots of information in it. I'm giving you some important information, and on the basis of that important information, if I can read it, if my eyes understand it, believe me, I can get multiple information about this request which is coming. The other attribute value which you are going to find is going to be NAS port type. So basically this NAS is also known as NAD in radius terminology, right? What is the port type of this? And the port type is suppose Ethernet. Believe me, with these two combination, if attribute service type is framed and port type is Ethernet, I am guaranteed, or I can say it 100% proof that this request has come from Ethernet wired. Believe me. Because who is sending this request? This request is sent by this switch. And this switch is setting up this attribute and value pairs. When it is receiving the request on 0/1 port, it is saying that this request is coming on my wired port and it has set these two parameters. And these are the standards. If service type is equal to frame, NAS port type is equal to Ethernet, the meaning is 0/1 port. This port is actually my wired Ethernet port. Believe me, for wireless, it is going to be something else, maybe 802.11. I don't know the standard, but it is something different. It is not Ethernet. Interesting, right? So don't you think that the request which you are getting, the radius access request which you are getting, right? You are designing this ISE. ISE can know multiple information from that request. Of one request, if I open this request, I get these two values. ISE should be absolutely sure about the fact that this client is connected over my wired port. Or maybe if NAS port type is 802.11, then ISE is absolutely sure, because ISE understand these radius messages. ISE can read, ISE can extract these attribute values to know something more about this access request. And now it is saying that the second request is coming is from the wireless client. And maybe you want to make your decisions on this fact that whether this client is wired or whether this client is wireless. Maybe you want to give wireless client more access as compared to wired client, or vice versa. It is your policy, right? Or maybe you want to do the simple thing, right? If Wired client comes, I would like to do EAP, protected EAP type of .1x authentication, or I would like to use this method of .1x. If it is wireless, I can do EAP, maybe TLS. Try to understand that this attribute and value pairs can give you some interesting information, and on the basis of that interesting information, you can decide what type or what method of EAP you want to do, or maybe some other important decisions you want to take, right? Right? So if you're designing this identity services engine, you should understand that this ISE should be understanding attribute and value pairs. It can extract those attribute value pairs to know more about this request, from where exactly it is coming. Is it coming from wired? It is coming from wireless? It is coming from maybe Apple iPad? Is it coming from Android phone? And so on, right? Once this is done, it is done, you can know what type of authentication or what method of authentication you would like to do. Maybe if you know that this client is wired, I would like to do protected EAP with it. Interesting, right? And this is what you are doing. This is basically you're designing this ISE, how our ISE is going to behave. And believe me, these are going to be known as your ISE policies at the end. Believe me, right? Once you have decided that the method you are trying to do is PEEP, for example, as a result of it, you are going to send a PEEP request, right? That I want to do a PEEP with you, right? And then in PEEP, you all know that the client is going to send the username and password, and server validity is going to be decided on the basis of certificate. But here is my point. You have decided, server has decided that it wants to do protected EAP with the client, and now client is sending its username and password. But here is my point. Where exactly you are going to match this username and password? You all know ISE can be connected to Active Directory right here, and ISE can also have its local username and password. By the way, this Active Directory is external to this I and that to the ISE, and we call it external identity source. And here, if we create username and password on the site itself, we say, or we call it internal identity. And here is my point. We are good that ICE wants to do EPEEP, but when Mr. Rahul send username and password, exactly where I would like to match this? I would like to match it to the external identity store, or I would like to match it to the internal identity store. We have to define it, right? Number 4, if we want to complete the authentication process, we need to define identity source, right? Interesting. Now I have decided the identity store. That identity store is going to be 80. So what is going to happen? When Rahul sends its username and password to identity services engine is going to check in this 80 whether it has Mr. Rahul and corresponding password. If it has, then 80, this identity services engine knows, right? Everything is good. Authentication is perfect. And it is going to say to the NAT back that yes, authentication wise, we are good. And I am sending access accept message to you. Access accept message means, in Radius terminology, it means that I am quite happy. I know that Mr. Rahul is exactly there in the database, AD database, right? I checked it. And on the basis of that, I'm saying Mr. Rahul was there. He's an employee, and you can just access or authorize this port. Previously, when the .1x authentication began, this port was not sending anything except e messages. And now you are saying you can open this port. But here is my point. Here is my question once again. How much should I open this port? Shall I give this port complete access, or shall I give it a port, maybe some restricted access? We need to define it, right? And I always explain this with an example, right? Right now, authentication portion is done. There is no doubt about it. The meaning is you are in front of a building and there is another guy who's a watchman there or the guard there, right? Yeah, NAD and NES is the same thing, Mr. Vikram here. So basically you are here and here is Mr. Guard and you shows your identity card and he sees it and he says, yes, you are good. You are part, you can access this building. This building has these several rooms. After showing this identity card, you can be inside this building, but wait a minute. These all rooms are locked. If you want to go in a particular room, you need a key. And that is where my question is. Authentication doesn't mean that you can go inside each of these rooms. Authentication just give you permission to let in, right? But from here, where are you going to go? Going to go is dependent on authorization. Maybe I can give you the key of room number 1 and 2, and then you can go and open room number 1 and 2, and basically 3, 4, 5, 6 is not for you. Maybe for somebody I can give access to all the keys, right? They can go and open all the rooms. It means that after authentication, you are brainstorming. This is you, right? We need to give authorization to this guy. I want this guy. I know, right? Rahul is authenticated. Rahul is a good guy. He's part of my organization. Now I am going to authenticate it. So, sorry, authorize it. So you can say that Mr. Rahul, because you are authenticated, I am giving you access of VLAN number 200. Maybe VLAN number 2, through VLAN number 200, you can go to internet and maybe to some servers, which is the requirement of this Mr. Rahul's job, right? Maybe Rahul belongs to engineering department, so he should have access to some engineering servers and then internet. And that is why I put him into the VLAN 200, as simple as that. So overall, these things you are going to see. But wait a minute, how do ISE is going to tell this information to NAD that you need to put the 0/1 interface into the VLAN 200, and here is the answer for that. You all know Identity Services Engine is sending access accept request, which means authentication is done. In this access accept request, we have attribute value pair, of course. And in this attribute value pair, Mr. Identity Services Engine is going to say that assign VLAN whose value is 200 to this port 0/1 port because I'm authorizing it. As simple as that. See the importance of attribute value pairs in this radius messages. When it comes, ICE is going to read it, right? And when ICE need to inform something to the switch, basically it is going to send into the attribute value pair. Don't worry about it. I am going to showcase you all these things. But if on this board, if you have any specific doubt, please do ask, because this is why behind policies. Because whatever you are seeing here, step number 2, or sorry, step number 3, the method you are going to choose, it is going to become your policy set. Inside the policy set, you are going to have multiple policies. Number 1 is authentication policy, and number 5 is authorization policy. So from 3, 4, 5 is your foundation or base of your policy sets. Believe me. Having said that, let's move to the next board where we will be seeing these things in Wireshark, whatever I have told you just now. Again, this is you who is brainstorming, right? Mr. Rahul sent an authentication, EAP message, right? And this EAP message is going to be encapsulated in radius. And just have a look at it, how this guy is reading. So here, right here, I am showcasing you this message, which is known as access request message, which is the radius message going from the switch towards ICE. And if I open it, I would like to showcase you the attribute value pairs. See the number of attribute value pairs which are going. AVP means attribute value pairs. And here is one interesting attribute value pair, which is service type framed. You can see it here. And another one is NAS port type, which is Ethernet. Interesting, right? Here. And as I mentioned, that if you have service type is equal to frame and NAS port type is equal to Ethernet, these two values are enough to make sure that the request is coming from wired client. And of course, it is 802.1x request. Interesting, right? And now suppose the radius or the identity services engine says I want to do peep with you or TLS with you, and after the message handshake, it knows that this Rahul is there in the Active Directory or the internal server, and it is sending a message back, and this message name is access accept message, which is I'm showcasing you here. Access accept message is itself a proof that the authentication is successful. Now, along with that, ICE is saying put your 0/1 port into VLAN number 200. And believe me, it sent this information also in this access accept message, which you can see right here. Right here. Just remember it or uh, take a screenshot of it, because I would be showcasing you this exact same thing in Identity Services Engine also. When I configure a authorization uh, policy, inside this authorization policy, I would be marking that assign VLAN 200. And when I mark this, then basically the attribute value pair which will be created, it is going to be like this tag 01200, and it is tunnel private group ID. Just try to remember it for this session only. Don't worry. Okay. So try to understand the value of these attribute value. So means the importance of these attribute values pair, right? Really interesting. So I think now you should understand why behind policies, what we are going to do. At the end of the day, what through ICE, what we are doing, we want only authorized person, or sorry, authenticated person. The person who belong to my organization, the machine who belong to my organization should become part of my network, and then I should give them the necessary authorization. For that, I need to identify this network device. And then I should identify or get to know more about these radius requests. Once I know about them through the attribute value pair, I can know that I want to do EPTLS with them or EPTLS with them, right? Once they are going to send their certificate or radius request, or their username and password, I can go ahead and check in my internal identity store or external identity store. Means I need to define my authentication rules. Where should I check them? Once I check them, and if I find them, then I need to define, right, authorization policy for them, or the authorization rule for them, that assign this guy VLAN number 200. As simple as that. So by the way, authorization doesn't mean that you can only say assign VLAN. You can assign ACLs over this port, and which is known as downloadable ACLs, DACLs, right? And there are so many things which you can do here on this port as a result of authentication success or failure. So this is exactly why behind Identity Services Engine, enough brainstorming, right? On the next page, I would like to showcase you where exactly or how exactly you are going to build these policies step by step, build these rules step by step. Authentication request came. After reading the attribute value pair, I came to know this is .1x client. If it is .1x client, I want to do EPIP, right? Once they are going to send their username and password, I will go and check the identity store. If it is there, I'm going to authorize it to VLAN number 200. As simple as that. Authentication and authorization policy, right? Or the rules. And that is what I'm going to explain you in the next board. Topic is policy set and policies. Believe me, it is really, really easy. So what is happening here is, again, the brainstorming is right here. You are doing all the brainstorming, right? And you get a radius access request. Inside this radius access request, you have multiple attribute and value pairs, which your eyes can read now. And we have these three different decision points, right? What is the meaning of decision point? We have orange decision point here, we have gray decision point, and we have blue decision point. What is the meaning? As soon as this radius access comes, I have to check this orange deciding factor, or whatever is written inside this orange, I need to check. And I have programmed eyes to go and do like this. So let's see what is written in this orange orange rectangle. Orange rectangle says, if attribute value pair, which is service type, and NAS port type, if NAS port type is equal to Ethernet and service type is equal to frame, right? Because I have received the radius access request, ICE can read it, and ICE is taking decision after reading the authentication request. And it is reading the attribute value pair. It is saying, okay, service type is frame, NAS port, NAS port type is equal to Ethernet. So it is taking the decision. The decision is, if this, then use EAP PEEP. Interesting. It is just saying that the radius access request, whatever is coming, I'm going to send it a challenge because it is the wired client, because I can see wire.1x request is coming. I can challenge it using EPEEP, and I want that the user should send the username and password to me. As simple as that. This is the whole sole point of this orange decision maker, right? First step of the ICE. And by the way, in future, you will be seeing this as, this is known as policy set. Only this thing is policy set, believe me. But what is the meaning of set? Set is a collection of data, right? You all know. And what we are talking about? We are talking about policy set. It means it is a connection of policies, right? If you see inside policy set, we are going to have policies. Do not worry about it. I'm just giving name to this orange decision making point. This orange decision making point is known as policy set. That is it. Now I know ICE knows that I have sent EPEEP, and I definitely expect that the user or the client or the supplicant is going to send username and password to me, because EPEEP, in EPEEP, client is going to verify me using my certificate. Definitely I will be sending it the certificate, but I also have to authenticate client using the username and password, right? Client is going to send me the user, although it is going to send the hash of username and password, but I have to check. ICE has to get ready for the fact that it is going to get username and password, right? But where exactly this username and password are going to be matched? We need to define it. And that is where I should go inside this policy set to know how I'm going to authenticate it, from where I'm going to authenticate it. And that is why I am exactly saying here, if .1x, if the client or the access request is 802.1x, which it is, or maybe the wire.1x, then check user in Active Directory, because I have to check username and password in Active Directory, right? So somewhere, maybe the internal store or maybe external store. External store is Active Directory. I'm going to check it. What exactly I'm doing it? If Rahul is sending his username and password, I'm going to check to the Active Directory to know whether Rahul is there or not. At this point, I am going to be absolutely sure about the fact that whether Rahul is part of my organization or not, whether this authentication is successful or not. So this gray color thing is actually your authentication policy. Believe where exactly this policy is? It is inside this orange umbrella, which is known as policy set. Interesting, right? Inside the policy set, we are having multiple policy. The first policy is authentication policy. Now, once authentication is done, I'm presuming that in Active Directory you have fine, Mr. Rahul was there. Rahul has passed authentication. Then you all know that if authentication is done, I need to specify where exactly or what VLAN I need to configure on the port where this .1x request was coming, right? So I'm writing, if 802.1x authentication gets success, then send attribute value pair VLAN equal to 200 on port. Interesting. And by the way, what I'm doing right here, this man is inside the building. Now I am giving keys of the rooms. What this process is known as authorization, right? And that is why this blue color decision making point is known as authorization policy. So we have at the top level orange policy set. Inside that we have collection of policies. First policy is authentication policy and the second policy is authorization policy. As simple as that. This is the whole sole policy structure of identity services engine. Really simple. I don't know. People say it is really hard. But yes, we still need to understand few things. For example, What is this if and else, if and then conditions, right? I am saying if. It means that this is my condition. It should be true. If I want to send active value, attribute value pair, VLAN 200 on port, right? And what is the condition? Condition is .1x authentication success. Whether this client or whether somebody, the request which came, has passed the authentication, then I'm going to send, right? And if it is a wired client, .1x. Similarly here also, I am saying if it is .1x, then I am going to check Active Directory. Even in the policy set, the starting point, we are specifically mentioning here, if the AV value pair is equal to Ethernet and frame, then use EPEEP. So basically this is a condition, and after then, whatever you see, this is my results. And by the way, these conditions and results are formed by little attributes, little values, which is known as dictionary. Although I just gave you a little bit clue about conditions, results, and the dictionary, but I will be talking about them in detail. Do not worry about it, because I was explaining the complete picture of the policies. So conditions, results, and dictionaries are inevitable piece of that. Having said that, it's already 40 minutes. Anybody, anyone would like to ask any question? Anyone? Okay, Mr. Vikram has question. Mr. Vikram, please go ahead.
Yeah, yeah, Vishnu, hi. So I would like to know what could be other than I mean, like we have studied about the frame, right?
Mhm,
Uh, a frame type, sorry, service type frame.
mhm.
So what could be other than this frame in the service type?
In the service type, I have to check because I really do not know about all the parameters, whatever there in the
Okay,
service type. I need to check. But
okay,
yes, in NAS port type field, right? Right now I am, and by the way, I will be opening it, opening the ICE, and you can check on your own. Don't worry. But in the
mm-hmm,
NAS port type field, definitely I can see multiple things. For example, if it is Ethernet, it is for wired. But
mm-hmm.
if we have 822.11 there or some other values, these are for a different thing. But believe me, I will be showcasing you that what different values can come here and what it can signify. I don't remember it, but it is right there in the ICE itself.
Okay, sure,
Okay,
sure, got it. Yeah.
perfect.
Mm-hmm. Thank you.
So now let's move to the next board. And now here is what exactly you are going to see, how you are going to see this thing in Identity Services Engine UI. Okay, so first thing first, if I show you, this is actually from here to here is actually my policy set, right? This is my policy set. Okay, and inside this policy set, you all know that we are going to have authentication policies from here to here. This is my authentication policies. And after that, I have my authorization policies. Maybe with some other color, maybe blue color. From here to here, I have my authorization policies. So inside policy set, you are going to have auth policies and authorization policy. And by the way, don't pay any attention to local exception and global expansion for now. It is going to confuse you, but we will be talking about it. It is very, very easy if you understand policies first. So let's talk about policy set. Whenever your access request comes to you with AV pairs, right? This is just the name .1x wired I have given. This is for my wired clients. And then condition is wired 822.1x. Believe me, if I open it, you are going to see attribute value pair. Attribute value pair are going to signify that the service type is something, and then the NAS port type is something. And if the value match, those are part of those wired.1x, right? So conditions, this is your condition. How you are coming across this condition, believe me, I will be explaining you, right? And if this condition met, if from the authentication request I came to know that this is my wired client, I will be doing ETLS with it. Allowed protocols means what through what protocol I want to authenticate or what method I want to authenticate this guy, and that is my ETLS. As simple as that. Once I have decided that I want to do ETLS with this guy, I know that the client is going to send me the certificate. If it is ETLS, if it is EPEEP, the client is going to send me the username and password because we know all these things, ETLS, PEEP, and all, right? And if I want to check that certificate, if I want to check that username and password, I need to have authentication policies inside this policy set. And that the first authentication policy which I am seeing here is this one, which is for .1x client. This is the name. And I'm saying wire.1x and go and check in bridgewire ARI. Actually, this is my external store. So this is my condition again in the authentication. If the request is coming, check whether it's wire.1x or not. If yes, of course I was doing IPTLS. But if the client is sending me the certificate or username and password, in case of IPTLS, it is going to send me the certificate. I need to check in using my Active Directory. So by the way, I have integrated my Active Directory with this name. That is why it is showing me this. Or if you want to check against the internal store, I can select it from here. I will be showcasing you. After this, there is going to be demonstration. Don't worry about it. Right? Once I find that the user was there, suppose the user has sent me the certificate. Inside the certificate, I will be seeing its common name. Inside the common name, it is written as Rahul. Of course, the certificate, I have to verify it. If I verify the certificate, then basically I can vouch that whatever is written on the certificate is correct. And the return name is Rahul. I'm going to check the Rahul in the Active Directory. If it is there, I will be saying that yes, the authentication is successful. Now, once the authentication is successful, right? So by the way, this was my condition, and the result was, means if condition was if 822.1x, I need to find it in my ARI. This was my result. And that is why everybody says that you need to create your results first and then create your policies. Why? Because if you don't have these results created, bridgewire ARI or .1x, how you are going to select in the policies at the first place? As simple as that, right? Now, if we talk about once the authentication policy set, we have seen we want to do EPLS. Inside EPLS, we are done with the authentication. Authentication is passed, suppose. Then we need to go ahead into this authorization policy to check what exactly it is. And maybe here I'm saying just if auth is passed, authentication is passed, then basically what you can do is you can give attribute value pair of VLAN 200, which means put that port in VLAN 200. As simple as that, right? This is just the policy set in the policies. But here is my question. The question here is, can we talk about more regarding these conditions and the results? Because these are looking really interesting to me.